Ever wondered how we can see things that are too small for the naked eye? Today, we're going to unravel that mystery. Welcome to the fascinating world of microscopes, an amazing invention that has revolutionized our understanding of life and matter. These ingenious devices are our window into a realm unseen, filled with organisms, cells, and even atoms. They have transformed fields like biology, medicine, geology, and material science, enabling us to explore and understand the world in ways our ancestors could only dream of. From the simple light microscope used in classrooms around the world, to the advanced electron and scanning probe microscopes that allow us to gaze into the atomic structure of materials, microscopes have been instrumental in many scientific breakthroughs. So are you ready to dive into the microscopic world and understand how microscopes work? Buckle up. First, we need to understand the main components of a microscope. Let's start with the objective lenses. These are the heart of the microscope, magnifying the tiny world beneath them into a size we can observe. They come in various magnifications, allowing us to examine specimens at different levels of detail. Think of them as your microscopic zoom function, getting you up close and personal with the unseen. Next, we have the eyepiece or ocular lens. This is where you place your eye and peer into the microscopic realm. The eyepiece further magnifies the image produced by the objective lenses, bringing the tiny world into crisp, clear focus for your viewing pleasure. Now let's talk about the stage. This is more than just a platform where you place your specimen. It's the stage for the microscopic drama that's about to unfold. Some microscopes come with a mechanical stage that allows you to move your specimen with precision, ensuring you don't miss an inch of the action. Last but not least, we have the illuminator. This is the spotlight that brings the microscopic world out of the darkness and into view. Located beneath the stage, the illuminator provides the necessary light to illuminate the specimen. In more sophisticated microscopes, you'll find adjustable light sources that can be tweaked for different applications, giving you the best possible view of your specimen. So, we've got our objective lenses for magnification, the eyepiece for viewing, the stage for specimen placement, and the illuminator for lighting. Each of these components plays a crucial role in the function of a microscope, working together to magnify, illuminate, and display the fascinating world that lies beyond the reach of our naked eyes. With these components working together, microscopes give us a window into the microscopic world. But how do different types of microscopes use these components? Let's find out. Microscopes come in all shapes and sizes, each with its unique capabilities. Let's start with the most familiar one, the optical microscope. This is your classic high school biology lab microscope, using lenses and visible light to magnify specimens. The optical microscope is a versatile tool capable of magnifying images up to 2,000 times their original size. Now let's crank up the power and move on to the electron microscope. This isn't your everyday microscope. It's an advanced piece of technology that uses a beam of electrons instead of light. The result? A mind-blowing magnification of up to 2 million times. That's like zooming in on a grain of sand until it appears as large as a football field. Electron microscopes can reveal details at the molecular level, allowing us to study viruses, proteins, and other tiny particles. But what if we want to go even smaller? Enter the scanning probe microscope. This ultra-high-tech microscope doesn't use light or electrons to observe specimens. Instead, it uses a physical probe that scans across the surface of the specimen, measuring the interactions between the probe and the specimen's surface. This gives us images with atomic-level detail, allowing us to literally see individual atoms. So whether you're looking at a cheek cell under an optical microscope, a virus under an electron microscope, or an atom under a scanning probe microscope, each tool offers a unique window into the microscopic world. But these are just 3 examples. There are many other types of microscopes out there, each specialized for different applications. From confocal microscopes that create 3D images of specimens, to fluorescence microscopes that use specific wavelengths of light to make certain structures glow, the world of microscopy is vast and varied. Each type of microscope has its strengths, but how exactly do they work to magnify the minuscule? Let's dig a little deeper. Now that we know the types of microscopes, it's time to understand how they function. Each type of microscope has its unique way of revealing the minuscule wonders of our world. Starting with the optical microscope, also known as the light microscope. This device works by using light and a series of lenses to magnify the specimen. As light passes through the specimen, it's bent or refracted, and then collected by the objective lens. This magnifies the image, which is then further magnified by the eyepiece lens, allowing us to see the intricate details of the specimen. Now let's move on to the electron microscope. This isn't your regular biology class microscope. Instead of using light, it utilizes a beam of fast-moving electrons. These electrons interact with the specimen, and the resulting patterns are detected and translated into a highly detailed image. This provides a much higher resolution and magnification compared to optical microscopes, enabling us to see things at the atomic level. Then we have the scanning probe microscope. This one doesn't use light or electrons. Instead, it uses a physical probe that scans over the surface of the specimen. As the probe moves, it measures various properties like force or current changes and maps these interactions to create a detailed topographic image of the surface. This allows us to view objects right down to their individual atoms. Each type of microscope, with its unique operation, offers us a different way to unlock the mysteries of the microscopic world. Whether it's viewing a single cell with an optical microscope, exploring the surface of a material with a scanning probe microscope, or peering into the atomic structure with an electron microscope, each provides us with a remarkable window into the unseen world around us. So there you have it. That's how these incredible devices allow us to explore the microscopic world. It's a fascinating journey, don't you think? From the simple bending of light to the complex interactions of electrons or physical probes, microscopes truly are marvels of scientific innovation. It's amazing, isn't it? We've journeyed through the intricate world of microscopes, from their essential components to the different types and their inner workings. Thanks for joining us on this journey into the microscopic world. Stay curious and keep exploring.